QA program at the baggaging or packaging area of your plant is important. And I have implemented systems before where we visually quantify items, and that has led to improper, gathering of data. So if you are a QA professional and you want to implement a packaging or crumb scoring scorecard for your particular bread product, obviously the manual scorecard is the way to go. But if you are thinking ahead and if you want to have additional data or ability to quantify other things, instrumentation like C-cell would really cut your work into half. Seriously, I am not joking on that one. If you spend 10 minutes grading or scoring one loaf of bread, C-cell is going to make that 2.5 minutes, So I've had QA techs spend 2 hours scoring a whole day of bread. And this particular instrument can cut that to maybe 15 minutes, right? So, that's why I
want to do it much quicker than that. I mean, one of the configurations we use is the equipment will be set up within the plant. So, so somewhere where you can get access to the sliced product pretty quickly. So after it's been chilled, probably just after the bagging line, and what typically happens in some bakeries here is they will take a loaf of bread every hour or a number of loaves, open the package. It's normally advisable to take samples from the same position throughout the loaf. But that goes into a little more detail about whether you're single piecing or 4-piece molding. You take a slice of bread, place it in the drawer, close the drawer, and it's all automated. So within 15 seconds of placing the sample in the drawer, we will have a bread score, which is a single figure score, which would be set up. It's a bespoke feature that's made for each customer. You have a single figure score, but behind that, all the data is saved. If you wanted to go in and look at the number of cells, it's all there in the background. But as an immediate quality control tool that isn't going to delay anybody, 15 seconds. And
that's good.
That's pretty good when you think it doesn't matter about the light, the ambient lighting that's around, because so much subjective assessment is influenced by the ambient lighting. And if the ambient lighting in one plant is different than another plant, you score it differently. With C-cell, if you have instruments at the side of the line, 15 seconds. And
that's faster than I thought.
Yes, yeah.
So yes, that's just my comment. Is I hope everyone follows my thinking on where to use this particular instrumentation to improve your productivity. Is C-cell designed only for English style white tinned breads with small cells, or can it test any types of breads and cakes?
Scientifically, any solid foam. So yes. Chemically or yeast leavened. And yes, we have done puff pastry. So things like vol au vent, very flaky layered pastry.
Oh, interesting.
French baguette, panini, pizza bases, all styles. So irrespective of the cellular structure, we will analyze, we'll be able to analyze the crumb structure.
Great. Can it look at products that are much smaller than a slice of bread, say something like a Cheeto?
Yes. We modify the system slightly, so not to become too technical, but the field of view with the standard machine is in the drawer, it's 7.5 inches by 5.5 inches. So that gives quite a large field of view. If we increase the magnification, we can go, sorry, I'm going to have to revert to metric. If we go to a higher magnification lens, we have a field of view that's probably 25 millimeters by 20 millimeters. So big enough to take something like the cross section of a slice of Cheeto, the savory.
I think the challenge there would be more like, how in the world would you slice a Cheeto?
Sandpaper.
No,
Yeah.
really?
Because it's such a low moisture product, you literally take the Cheeto on end, the same way as you put it into your mouth, rub it on sandpaper, and it removes the outer layer perfectly. Yeah. Then a little blast of compressed air, and you can do it either, you can do the cross section or you can do it longitudinally. Because when you're making snack foods in an extruder, you get a similar elongation of the cells because the extruder is flowing at quite high speed. So it actually starts to elongate the cells in a similar way to the dough being sheeted. So yes, we can look at small snack foods.
Wow.
That's a dedicated machine.
Okay. Learned something new today. So Stephen, how accurate is the equipment?
If you put the same sample, if you take repeat readings, we'll get within 3%.
That's very good.
So when you're looking at an instrument with a sample with maybe 10,000 cells, so it's yeah, around 3%.
Very good. That's pretty precise.
And from instrument to instrument, again, it's very accurate. We had to comply. We had to do a number of ring tests in association with AACC in order to get an approved method. So
all right,
it's an accurate tool.
Great. You know, when we want to measure sesame seeds, we have to calibrate it first. How many samples do you require to create a calibration to measure sesame seeds on the top of the hamburger bun?
Around 50 to 70. The important thing is that you cover the range. I don't know whether anyone's familiar with developing NIR calibrations, but we have to see well, you know, it normally takes a lot more samples than 50
Oh my God, that's such a headache.
We have to see the expected range. So from a completely naked surface with 0 seeds up to something that maybe is double dosed. So it's hard to say, but normally we can get enough information from about 50 to 70, but also it's important that we see them sometimes when the deposit has gone wrong and they're all deposited in one quadrant. There's no point having the correct amount of seeds there, but they're all in one quarter. So it's covering all the variations with all of the bespoke stuff that we do with the bread scoring, with the sesame seeds or the cake. it's seeing as much of the natural variation that they would see on the plant. And the idea is the software can then say, I can go back into my library of examples. I've seen an example like this, and that's the result.
Yeah, I totally agree. I have seen sesame seeds problems, just not from the depositor itself, but from the size of the sesame seeds. So for the new supplier, and all this, whether the sesame seed oil content is going to affect the depositing, all these are going to affect the final quality. And sometimes,
well, also the shade. I mean,
fast enough.
From one year to another, the shade of the sesame seeds changes. So that can have an impact. Now that you obviously can't source sesame seeds from every different harvest, but again, we can then make slight adjustments.
So when comparing standard and clean label tests, how many repetitions each do we have to carry out to get an average? Is it within a loaf or is it across loaves?
That's more to do with your laboratory practice than the equipment. My personal view would be, I would take a minimum of 3 slices per loaf. And if you've done test bakes, probably 3 different loaves, 4 different loaves. But that really depends on your test kitchen, the capability of it. The important thing I would say is always take the slices from the same locations.
So across loaves?
Yes.
Okay.
So, if you're producing 17 slices, take slice 6, 12, and 15, something like that. So everybody, and also it's critical. Obviously, when you take a slice of bread out of a loaf, it has 2 faces. So we should all be putting the sample into the drawer with the same orientation, because if you're looking for some of the features with things like farmhouse bread, sometimes you'll get more sidewall collapse on one side than the other, depending on where it's gone through in the oven. Mm-hmm. So it's important to always take the same slice, or take the same from the same location, but also how you then place it into the drawer is the same. If we all do that, everybody gets the same results. So there's no user differences.
Right. All right. There was a slide that you were showing just now of all the 48 parameters. Which ones are important to the industrial baker?
To start with, I would say you start off with obviously things like the slice area, the height. It depends what style of bread. If you're making tinned bread, if you're making tinned and lidded, or you're making hearth. But as a general rule, if you're making tin bread, I would say the height, the slice area is critical. The cells, the number of cells, the average cell diameter are critical measurements. Cell wall thickness is an important number, because you can impact the cell wall thickness with different improver systems. So you will change the characteristics. You will change how the dough mixes with different ingredients, and that will impact. So area, height, cell information, elongation is important, because then if you are sheeting and rolling, then the pressure on the rollers, in some ways it's good because you're elongating the cell, but if you put too much pressure, you then start to lose cells. They actually get expelled from. So it will give you information about the raw materials and the processing of the dough. But then as you move forward, different styles of bread. Here in the UK, we do a lot of what's called tinned and lidded. So very rectangular. So it sits in a tin, and then there's a lid placed on the top. Now, a lot of that bread goes towards sandwich making. So they'll package them then. They'll add 2 pieces of bread with a filling, cut them into 2 triangles, and it goes into packaging. So for those kind of processors, they are obsessed with the overall shape. Although it's rectangular, roughly in profile, they want to know, has it filled the bottom left-hand corner of the tin? Has it filled the bottom? So we get nice, sharp right angles at the bottom and the top. So things like the top and the bottom shoulders are critical. If you're looking at improving the overall quality of your bread, then you can start to break down the individual processes within the baking industry. So the sheeting and rolling is one. The dough mixing, if we overmix, what's the consequence of overmixing? Do we start to lose cells? Yeast, if yeast starts to lose its activity, where will we see that? Well, normally you will see it in a reduced number of cells. Is the prover working okay? So although you start off with maybe 6 or 8 parameters, then as you sort of grow with the equipment, you've got a handle, you've got your set points for how many cells we expect within a slice. You then start to refine your process more, and you look at alternatives. You know, one supplier compared to another supplier, what are the benefits of both? And by test baking side by side, it gives you a very accurate insight. Very poor and very good are obvious to everybody. As they get closer together, it starts to become a little difficult for everybody to say, well, that one is A is better than B. And that can have huge cost implications, especially when you're looking to move to clean label or enzyme based products, because these are very expensive. You're using them at ppm levels. So it becomes a very expensive decision. Is formulation A better than B? And what are the cost implications of that?
Right. The conversation on sesame seeds makes me think about chocolate chips visible on the surface of a cookie. Can the T-cell evaluate this? So can it count cookie chips, or can it count how well it's dispersed? And do you need, calibration for that as well?
Yes, to everything.
Okay.
Yes, we can do it. Yes, it would need a calibration developing. And again, it would, with something like chocolate chip cookies, it would be again about 50 to 70 images from under the prescribed level of chocolate chips on the surface to over. So underdose, overdose, and perfect. Covering the background base color of the cookie is critical as well. So we wouldn't want to take samples all from one batch, because what we're doing is color separation. So maybe some of the background cookies are undercooked or slightly overcooked. We need to build that variation into the calibration. We went as far as for somebody not too far away from you, they have a test that they carry out where they're looking at, they make a certain type of cookie, and they're looking, or they were subjectively assessing the cracking on the surface of the cookie. That we automated. We developed an algorithm to do that. So that's running in that machine that isn't too far away from you. So it would give, and all we used was the people that were doing the assessing. They were the bakers, and they were assessing from 0 had no cracking, 10 had far too much. They
Wow.
sent me a selection of images, and then we developed the algorithm based.
Oh, nice. I would never have known how to measure the tracking.
It like with most things, sensory scoring is down to how long you've been there. The more experience, the more times you see these loaves of bread or cookies flying past, you think that's quite a good one today, and it's just putting numbers on it.
That's true. This is a question from Andrew from Kansas. We recently purchased a C-cell, and I was wondering if you might be able to elaborate on the coarse/fine clustering data points.
Right. What this is one of the images I haven't included in the presentation, but it's giving you on, well, for Andrew it will make sense. There is one of the processed images that splits the slice into red and blue areas. And what the difference is, we find the average cell diameter, and then any of the cells that are below the average diameter are color-coded blue, and any that are above are color-coded red. And the idea is to look at whether we have an even distribution of coarse and fine cell structure, or whether we have something separating out to the top. A typical example that most people can imagine is if you have a cake batter, it's a much slacker dough than a typical bread. And it's also made in a different way, but you've got a high-speed mixer making a batter. So you've aerated that. If you left that aerated sample for maybe an hour and then baked it, you would find that all of the coarse or the larger cells would have migrated towards the top of the cake, and the smaller ones stay lower down. So the coarse and fine clustering and some of the numbers associated with that, look at the distribution. Have we got an even distribution, or because of the way we're processing the dough, is it we have all the small cells at the top or at the bottom?
Even we see that at the dough processing side of things, when a dough is mixed at such a huge volume, and it takes 20 minutes to process, right, from beginning to end. The beginning dough is always going to show a tighter crumb structure, and the end dough is always going to show a bigger, wider crumb structure. And instrumentation like that would actually help us and tell us whether the dough is sitting in there too long, because that in some volumetric depositors, that is a huge issue.
Yeah, because this was one of the trends from maybe 10 years ago, was they wanted a bigger and bigger mixer. They thought bigger is better if we can mix 250 kilos. Now it's reversed completely.
Yes.
100-kilo mixers are much better.
Because people finally figured it out. Hey, maybe big mixers are not the way to go. Maybe smaller mixers and more of them are better. I'm glad people have thought about that.
I mean, that's quite easy to show up in C-cell. But yeah, I mean, if Andrew wants to contact me, normally, certainly in the US, I will install everything and train people. The problem has been the last 12 months. So, but I'm still hopeful that one day soon we'll all be able to travel again.
I'm sure. I can see the end in sight, Stephen, of all the vaccinations coming.
Yeah,
we're getting there sooner than later.
So let's hope before the end of this year I can get back.
Yeah. Anyway, if anyone has any more questions on this particular instrumentation and how to use it, reach out to Rachel at rgibson@calibercontrol.com. and her email is right there in the chat box. And to learn more about this particular C-cell, go to bakingqualityanalyzer.com. We have come to the end of a session, Stephen. Thank you so much for joining me.
Thank you, and thank you for everyone's time.
Yes, and if you have any more questions, go to bakerpedia.com/forums, and we can have more conversations there. Thank you, everyone.
Great.
Bye-bye.
Thank you. Bye.